Welcome to part two of our three-part series on diagrams and how to use them to troubleshoot. Today's TAS Academy HVAC training video is following sequence of operations through the pictorial diagram with your host, Total Air Supply Technical Support Manager and Trainer, Randall Ripley. The sequence of operations can be found in the installation manual that comes with the equipment. This is from the AR9T96 R32 Ready two-stage non-communicating furnace. As you can see, it states at the top of the page, normal sequence of operations, and then you go over to where my yellow box is, and that's the heating sequence, and it starts telling you step by step how the furnace will start up, run, and then what it should do when it's shutting down. Sequence of operations is the process in which a heating or air conditioning system starts up, from the thermostat call to the thermostat ending the call. Understanding the sequence of operations is a troubleshooting tool you will want in your toolbox. Knowing how the equipment is supposed to start up establishes a starting point. I prefer to call it a reference point of where to start your troubleshooting based on what the unit is doing and what it should be doing. In part three of this series, we will use sequence of operations and an electrical meter to troubleshoot simulated failures in the sequence. So let's jump right into this. Upon being powered up, the control board will perform internal and polarity checks. The control will display IDL, idle mode, until a call from the thermostat is received. And you see the idle on the 7-pin segments boards there, little LED boards. On a call for heat, the thermostat contacts close and send a 24-volt signal to the W1 terminal on the control board. The control board microcomputer begins its self-check routine. You will also see that the board from now on will start alternating between GA1 and FO1, which is your first stage call for heat and your first stage call for the blower airflow or speed. The control verifies the auxiliary switches, and the primary limit switch is closed by sending out 24 volts on pin 1, a pink wire, of the 12-pin connector through the auxiliary limits on to the primary limit and back down on the red wire to pin 8 of the 12-pin connector, as we see here in the diagram. And the red wire, why is that going back to the 12-pin connector? That's the step that proves that those three switches are closed, because we're in the pre-check phase and the board wants to see that those switches are closed. Then we'll move on to the 24-volt split at the primary limit control and travels on a purple wire up to the inlet side of the first rollout switch, changes to a pink wire and goes over to the second rollout switch. Then travels from the outlet of the second rollout switch on a purple wire down to the number 12 pin on your 12-pin connector, proving the rollouts are closed. So now we have all of our switches here closed. So now we want to move on to our pressure switches. The power splits at the outlet of the second rollout switch and goes up to the inlet side of the low fire pressure switch on an orange wire, and then over to the second stage pressure switch on a yellow wire. This proves that the pressure switches are open because the voltage doesn't travel back on the outlet orange wire to pin 5 of the 12 pin connector, and also the yellow wire that goes back to the 12 pin connector isn't going back either. But if it was, you would see, like on our first stage, you see that goes down to the 5 pin. That would show that pressure switch is stuck, and you'd get an error code that the pressure switch is stuck closed. The control module performs a gas valve circuitry check. To verify gas valve relay state, both the first and second stage relays on the board will be open, and there will be no voltage at the gas valve. Even if the gas valve relays were closed, you still would not measure voltage at the gas valve because the front cover pressure switch that breaks the common wire is open, so there's no complete circuit to open the valve. As any circuit that uses energy rather than pass it, like a switch, a coil, a motor, there has to be a complete path back. The hot leg on the common or the neutral, and back to the panel. So now that we've passed our checks, the power venter motor is energized. The pre-purge period begins once the low fire pressure switch is detected closed. That means that the inducer motor has gotten up to speed, and that closes that. And we now have power on pin 5, and that's going to activate the process. But let's get to the front cover pressure switch will close at this time also. The gas valve common is now closed. So that proving step, the pressure switch closed, the low fire, now we've proven that the front cover pressure switch is closed. We now have a path back. After completion of the pre-purge, the control will energize the igniter, because that's where we're at now. The gas valve isn't open yet, isn't powered yet, but the common has closed. Then we see our igniter will ignite. It will start its warm-up period. After completion of the igniter warm-up period, the first stage of the gas valve is energized by pin 10 on the 12-pin connector plug, and goes to the gas valve low side on a white wire. And it's actually gray, but you can't use white on a white background. The front cover pressure switch is closed, allowing a complete circuit to be made, the gas valve to energize, and the burners to ignite. Now we have ignition. The igniter is de-energized as soon as the flame is sensed. After 30 seconds, the indoor blower motor is energized on first stage heating speed. When using a single stage heating thermostat, the furnace will transition to second stage gas heat by either a fixed time or auto mode, depending on the menu selections made by the installer. This particular model, the timer on the board when you want to use the single stage thermostat can be anywhere from 10 minutes to 60 minutes. And it's anywhere from 2 to 11, I believe, but not more than 11 on the auto time. The inducer motor is enabled at high speed, closing the second stage pressure switch and allowing the 24 volts to travel down the yellow pin 9 wire to pin 9 on the 12-pin connector, confirming the second stage pressure switch has closed. This will energize the high fire stage of the gas valve, and the second stage gas heat speed of the indoor blower motor is energized as well. Call for second stage heat when using a two-stage thermostat, true two-stage. The furnace control board receives a 24-volt signal from the thermostat on W2. All other steps are the same as the previous slide. And why it's called true two-stage is because the thermostat determines when you go to high fire by a differential that you set up in the thermostat. The shutdown sequence, when the thermostat satisfies, reaches the set point, the call on W1, W2, if applicable, will be removed. The gas valve is de-energized and the burners go out. The inducer remains on the post-purge period of 15 seconds. As the inducer shuts down, the pressure switches will open. The indoor blower runs for the selected off delay period, 90 seconds by default, but it is adjustable from 30 to 180 seconds. Don't miss part 3 of this series as we close it out by troubleshooting simulated failures in the sequence of operations and what could have caused them. We will use troubleshooting charts, meters, and discuss other things that can cause failures. So what we will do is we'll have simulated failures as we go through the sequence of operations and at each level, and then we'll discuss what could cause that using troubleshooting charts. And then little meters will pop up on the diagram to show where we would measure for that, at what points. And that way, we're not going to go to a furnace and do it or anything. We're going to do it right on the diagram just so you get more familiar with diagrams. The better you can read diagrams, the better off you're going to be going forward in this trade. Thank you for watching the video. I hope you enjoyed it. If you enjoyed the video, please hit the like button. And if you would like to get notifications of each of our videos when they drop, hit the subscribe button. Thank you for watching. You can watch all of Taz Academy's videos at the website shown here. And then this is my email. Again, thanks for watching, and I hope you come back to see more.